Okay, we're up to 25. Let's keep this ball rolling, guys. So the first thing is, it says, use the graph to find where it is increasing. Now it's very important you recall that on these questions we need to know that this is left to right logic. Same thing for decreasing. So as we move left to right, where is it going? Up. Well, because it's left to right, let's start on the furthest left point here and realize that from here to here it is going up. So I'm going to make this green. From here to here it's going up, and from here to here it's going up. Now we're going to have to use some guesstimation here because of the graph that I've provided, but it looks like from infinity, so it is increasing along left to right from negative infinity. X is greater than negative infinity, but it also, I'm going to say that's negative 5. Well, hold on. 2, 4, 6, 8, 10. So these are 2's. So I'm going to say that this is a negative 1. So all the way to negative 1 it's going up. But also it's going up from 0. So from 0 all the way up to, and if these are chunks of 2, I'd say that's like 1.75. I'm just guessing. Your graph on your exam will be much clearer, so your points are more obvious. Now, where is it decreasing? Well, it'd be decreasing from here, which we're saying, oh, that's negative 1 there. It's decreasing from negative 1 all the way to 0, and it's decreasing from here, which we said was 1.75 to the right, because we realized that these are chunks of 2. So from 1.75, whoops, just put forever, because this is going down forever. So there's decreasing and increasing. Now, as far as concavity goes, concave up, concave down. Remember, the generic idea is if you move left and right and you're going up, it's concave up. If you're moving left and right and it's going down, that'd be considered concave down. So a good memory tool, concave up spells cup. So you're looking for cups for concavity being up. So where are our cups? Well, I see a cup from here to here. It's a portion of a cup. But from here to here, we have concavity up, both directions moving up. So again, I know these numbers are kind of strange, but from negative 1 all the way to that point, 1.75, we have a cup. Now, concavity down, we're looking for an upside down cup, and we could say that that happens from here to here, and from here to here. So there's 2 upside down cups. So this would be from negative infinity all the way to 0, and from 0 all the way to infinity. All right, local maximum, well, that's the highest point. These are chunks of 2, so we'll just say that right there, 12, we'll say that's 13. So that's, we've decided 1.75 comma 13, so that would be our highest point, so that'd be 13. Local minimum, I know these go down forever, so we might be tempted to think negative infinity, but they're looking for this. Where does it bottom out on one of the transition points? And that's right there, 0. Okay, little disclaimer, another moment for me to be honest. I never looked at these. So, I got this graph from Desmos. These little dots actually give you the exact points, locations, And I didn't use them, but I'm not going to chew up the rest of this video just redoing that problem. So for example, I said this is 1.75, but it's actually 1.6. I said this is about 13, but it's actually 13.1. So you'd have to insert all of these actual values into these answers. So if you have questions on that one, please come see me. Didn't mean to lose you there. All right, number 26. This is a difference of two squares, so we're going to go 2 sine theta minus 1 and 2 sine theta plus 1. Now we got to realize they both equal 0, so we're going to go 2 sine theta minus 1 equals 0, and then we're going to solve this one. So 2 sine theta equals 1, so divide both sides by 2, I get a half. Now, if I went and did the same thing for this one, 2 sine theta plus 1 equals 0, subtract 1, subtract 1. 2 sine of theta equals negative 1, divide by 2, divide by 2. Sine of theta equals negative 1 half. So, they're asking us, where is this true and where is that true? Well, notice sine is positive for this one, sine is negative for this one. So we're looking for, where does sine equal 1 half? Well, remember, in our 30-degree triangle, the opposite side is half the hypotenuse, and we have that right here. So one of our answers is 30 degrees. If I check it out over here at 30 degrees reference angle, I've got 1 and 2, so I've got that situation here. But I'd have to spin my spinner 150 degrees to get to this picture. But the same, where's sine equal negative 1 half? Well, that'd be here, because that's a negative 1 and a 2. Reference angle 30, so that'd be 180 plus 30, which is 210. And the final place where this can happen is right here, negative 1, 2. And how far did I spin my spinner? Well, that'd be 330 degrees. So there'd be my 4 answers for that problem. All right, 27. Sketch the graph of, and you should be able to look at that and go, aha, that looks like the general equation of a circle. So because of this, we know the center is going to be 0, 0. And we know if this is r squared, then we take the square root of that to find out what r is, and it's 5. So 1, 2, 3, 4, 5. 5, 5. So we just kind of pick that out, do our best, and there we go. But it says determine the restriction on the domain to make it pass the definition of being a function. But if our understanding of knowing that to test a graph for being a function, we use the vertical line test. If we drew a line in here, we can see that it would intersect the circle in 2 places. Therefore, it's not a function as it is. But in order to restrict the domain, in other words, if we took part of the domain off, so let's say we considered that chunk, it would still fail, still fail, still fail, still fail. So we can't restrict the domain, we need to restrict the range. In other words, if I said, you know what, let's let y be, in other words, if we took the bottom half of this graph out, we'd say y is greater than or equal to 0 and less than or equal to 5, that would now pass the vertical line test. Or if I restricted it to y, let's say I took out the top half, in other words, we're going to restrict the range, y is greater than or equal to 0, less than or equal to negative 5, because that's negative 5. So we wouldn't be able to restrict the domain, we'd need to restrict the range. So I'm going to have to change that on your actual exam review, but no big deal. Let's move on to number 28. So, number 28, sorry about the previous problem bleeding through there. It says sketch the graph of y equals tangent of theta. Now, it says show 4 asymptotes. We've done a lot of these in class, so we should know that tangent Opposite over adjacent, in other words, where does the adjacent turn into 0? That's where our asymptotes are. So if we recall, if we go here, 0 degrees, we got our adjacent side. That is not one of our restrictions. But if we went to 90 degrees, we could see the adjacent side disappears, and also 270, which we talked about on a previous problem not too long ago. So here's where our restrictions are, 90. But that's also the same thing as negative 90. 270 is the same thing as negative 90. So we know that we have a restriction at pi over 2. We have a restriction at negative pi over 2. And this just goes on every 180. And if we recall, the tangent function looks something like this. We went over this a lot in class, so I'm not going to bore you with the explanation again. So there's tangent. It says then determine the domain, the range. Now the range is quite easy because it goes up and down forever, so that's all real numbers. The x-intercepts are going to be written slightly different. So, according to y equals tangent, and they're asking for the domain, we know that x cannot be any of these pi over 2, negative pi over 2, negative 3 pi over 2, or 3 pi over 2. So how do we write that? Well, for this particular problem, we know the domain, remember it says show 4 asymptotes. These are what x cannot equal. So these are going to be our limitations on our domain with the restrictions of showing 4 asymptotes. So we can say x cannot equal negative 3 pi over 2. It cannot equal negative pi over 2. It can't equal pi over 2 or 3 pi over 2. Or any of these plus 180. Plus or minus 180, essentially. And then the x-intercepts on this particular window, the only x-intercepts we have are right here. So the x-intercepts are negative pi, 0, 0, 0, and pi, 0. There's our x-intercepts. Okay, so we have a problem where we just have to use some algebra here. So it says solve. Now there's going to be many ways that people are going to attack this, but I'm going to get rid of these fractions here by multiplying by 6. 3 goes into 6 twice. 2 times 2 is 4x. Half of 6 is 3. There, I cleaned it up. Now I'm going to clean this one up too. I'm going to multiply this by 10 just to move that decimal place. So I would get 2x plus 10y equals 40. Now, I'm actually going to divide this by 2 now. I'm sure there'd be a different way for different people, but 5y equals 40. Now, what I'm going to do is I'm going to use good old elimination. I'm going to stack these two equations. I'm going to multiply this by negative 4 to eliminate my x's. So negative 4x minus 20y equals negative 160. Well, I'm just on a roll, catching myself making some mistakes all over the place. 40 divided by 2 is not 40, it's 20. So negative 4 times 20 is not negative 160, it's negative 80. And here we go. So we're going to add these together. We get negative 17y equals, that'd be negative 68. Divide by negative 17, divide by negative 17, we go y is 4, believe it or not. So now, where do I find x? Well, find it in the easiest place possible. I'm going to go to this guy that I almost screwed up. So x plus 5 times y equals 20. That's 20, so if I subtract 20 from both sides, I get x is 0. So these two lines would intersect at 0, 4. Simplification problem here. All right, square root of 75, that breaks down into 25 and 3. I'm going to clean this up. This is 5 times 2, which is 10. 32. That's negative 3 square root of 16 square root of 2. This is 4 times negative 3, which is negative 12 square root of 2. And this is just square root of 9 square root of 3, which is just 3 square root of 3. I'm not done until I research, are there some like radicals? Yes. So 13 square root of 3 minus 12 square root of 2. All right, I think I can squeeze in number 31. It's a quick hitter. Even, odd, or neither. So we look at the graph. Remember our rules. Look at this one. If we flipped it over the y-axis, it'd be the same graph. That means it's even. Let's jump down to letter C. If I drove a nail through the table here and I spun this 180 degrees, which is always hard to do. Oh boy, okay. So if I spun that 180 degrees, this portion would spin right down here, this portion would spin right up there. So essentially it's the same graph spinning about the origin. That makes this an odd. And this one doesn't follow that one, and it doesn't follow that one. So this is neither. All right, that should be a pretty simple problem for you guys. And that finishes this video.